All right, we have been working with some of these. See, now you guys are all going to be super quiet. It's like, oh my gosh, he's recording stuff. It's okay. It'll be all right. We've been working with some of these formulas. Who can tell me one of the two formulas we had worked with the last couple days? Nick? C equals
H.
We got an H frequency, but that equals the energy. I love it. Totally another formula. C equals lambda nu. C stands for
Speed of light.
speed of light. Lambda equals
Wavelength.
wavelength. And nu equals
Frequency.
frequency. On it. I like it. E stands for
Energy.
energy. H is Planck's constant. Good. And nu stands for
Frequency.
Oh, you know what? Or whatever.
That's nice.
So frequency used in both formulas. How are we doing on our formulas here?
Good.
Doing okay? Okay, I want to do one more kind of warm-up problem with you guys. I also want to show this one because it's a little bit different than what we have seen before on some of these calculations. So let's go back to this first one that we skipped over a couple days ago. What is the frequency of a photon of light with a wavelength of 550 nanometers? Well, what are we looking for?
Frequency.
Looking for the frequency. So what is the frequency? I'm going to just go ahead and put my new question mark. What else do we know? What's the number in your measuring?
Wavelength.
Wavelength. So here is our lambda. Well, we've got lambda. We're looking for frequency. Which formula are we going to use? Top one. We're going to use this speed of light. I'm going to go ahead, just so I know which one I'm using. C equals lambda nu. Do we know C?
Yes.
Yep. It's a constant. Never changes. By definition, that's what constants do. Nothing. 3.00 times 10 to the 8th meters per second. There's our C. We're just plugging it in. Lambda. Do we know lambda?
Indeed.
Yeah. From our question, we know the wavelength of this particular wave is 550 nanometers. And we're trying to solve for the frequency. Now, we know we got to divide because right now we got a variable times number, but what's wrong with our number here?
The units don't
The
match
units.
up.
The units. If we were to solve it just the way we have it right now, nanometers and meters aren't going to cancel. We're going to have to, it would make nanometers meters per second.
No.
Sorry, I take that back. It would be meters per nanometer second is how it actually would go. It would be ugly. So, the way we have it written right now, we got to do something. This ain't going to work. So we need to change our units. Now, nanometers. Did we talk about nanometers?
No.
No, we never talked about nano. It is a metric prefix, nano. It is really little. Really little. And if you look on your handout there, I think right above number 1, it says that 1 meter is equal to 1 times 10 to the 9th nanometer.
That's wow.
Crazy little. Crazy little. So 1 nanometer is a billionth of a meter. Nope. Yeah. Nope.
Yeah.
Millionth is 6, right?
Yeah.
Yeah, so billionth is a billion. Good. So we're going to need to change the units. So I'm just going to pull out the 550. Put it over 1. Ooh. It's 1 stepper. Nanometers go on bottom. There'll be 1 meter on top. Somebody got a calculator handy. What's 550 divided by 1 times 10 to the 9th? Oh, yeah. 5. I think it's going to be 5.5. Just divided by 1. 5.5. 10 to the -7.
Oh, okay, I said the answer. Sorry.
Oh, gotcha. Gotcha. Here is our measurement in meters. This is what we're going to take and plug in the wavelength spot. We can't use nanometers. It's got to be in meters. So, put our 5.5 times 10 to the -7 meters. Meters on the left, meters on the right. let's go ahead and solve. How are you going to solve frequency?
Math.
You're going to math it. Number times a variable, we do the opposite. What you do to one side, we must do to the other. Yeah, so your answer, we'll take 3.00 times 10 to the 8th, divided by 5.5 times 10 to the negative 7th. Ooh, meters cancel, becomes 1 per second.
Now
1 per second. So think of it this way, guys. 2 divided by 2 is what? 1. When you divide something by itself, it turns into a 1. So this is still 1 per second. And that's good because that's the unit for frequency. That's what we're looking for.
I'm just curious, with the rule of like whenever you divide, do you subtract the exponents?
You would. So 8 plus a 7.
It's,
But I think because we're taking 3 divided by 5, I think we're still going to say 14. Yeah. Somebody plug this in. Times 10. What do you got? 5.45.
Hey, let's all say it.
5.45 times 10 to the 14th. And what did we say our units were?
1 per second.
1 per second. Or you could say hertz. They mean the same thing. Don't check our sig figs. How many sig figs?
3,
3. How many sig figs?
2.
Oh. 5.5 is only 2 sig figs, so this becomes 5.5.
So we do the lowest one?
We can only be as precise as our least precise measure.
Why do you always say go back to the first one?
This one was 2 sig figs.
Then it's so precise that it's